factor completely, x plus 3 on the top, difference of squares on the bottom, x plus 3, x minus 3. List our non-permissible values, x can't equal negative 3, and x can't equal 3. And if we check, look at this, we have two that are identical. So I'm going to have to take out my green pen because I'm going to rewrite my simplified equation. Careful. Some of you will be tempted to do this. This is not right. Why not? Didn't everything just cancel out? Am I not just left with an x minus 3? Right? That's all I'm left with. But that x minus 3 is in a denominator. Technically, when you cancel things out, it's not like they simplify to become ones, right? And you see that you would still have, oh, whoa, black line. There we go. Do you see that you still have a 1 in your numerator? So since something cancels out, now we have to decide what are our non-permissible values going to be. Are they going to be wholes or are they going to be asymptotes? Well, the one that doesn't cancel out, that's still a vertical asymptote. But the one that does cancel out becomes a whole or a point of discontinuity. And that whole is going to happen when the x value is negative 3. How do we find the y value? Well, it's not a non-permissible value for the green one, so we go, I could just plug in minus 3 for x into the green equation, and I now get 1 over negative 6. That's the coordinates of the whole. So you get that y coordinate by plugging into your new equation. And when you do have a whole, now everything you do from now on is just graphing this in the green box and adding the whole. So now, when we move on to step 3, if there's horizontal asymptotes or oblique asymptotes, we don't look at the original equation anymore. We look at what's in the green equation. Typically, ones with holes end up being just a straight line with a hole. And then you don't have to keep going with the rational graph steps. But this one is still a rational graph. In fact, it's the type where the degree is bigger on the bottom. It's type 3. Did type 3 have oblique asymptotes or horizontal asymptotes? I think this one is the easiest one. Whenever it's bigger on the bottom, you have a horizontal asymptote at y equals 0. And once you're done your asymptotes, I would start graphing. On my axis, I have an asymptote at 3. Another one at 0. I have a hole. I can put that hole already on my graph. Negative 3, 1, 2, 3, negative 1, 6. It'll be right about there. Find my y-intercepts and x-intercepts. Y-intercept is the easiest. Plug in 0 for x. Again, now we don't go to our original equation. We are now graphing the green equation, so when I plug in 0, I just go to my green equation. In this case, it wouldn't matter. It'll be the same numbers if you would have went to your original equation. But we get 0, negative 1/3. And x-intercepts, that's where your numerator is equal to 0. There won't be any, because my numerator is a 1. My numerator can never equal 0. So technically, I have enough to do section 1. Right? The graph is in 2 sections right now. With the whole. y-intercept. I have enough to graph section 1. I have nothing in section 2, so I might choose a nice point like plugging in 4. You see that if you plug in 4, you're going to get 4, comma 1. Go to my graph, 4, comma 1. And that's enough to go towards the asymptote there and there. So here we have a regular graph with a hole. Could they have more than one hole? Super easy. If I want another hole in this same graph, I just have to have an x plus 2 on the top and x plus 2 on the bottom. I'd have another hole. You can add as many holes to a graph as you want. Alright, and it's crazy because in the textbook, like I just said, this is like a favorite one that the exam likes to use, but there's no real examples in the textbook like this one. So I'll give you a review instead of questions here.